Evening, everyone. I think some of you might have came here to see Sebastian. Unfortunately, Sebastian couldn't make it tonight. He's the founder and CTO of Weeve Network. And tonight, I'm going to empathize and tell you a bit about trusted oracles and why we think trusted oracles are important for the Nature 2.0 track. First, how many of you here are developers out of curiosity? Because this is a plugin event. Oh, not that many. Okay, great. Unfortunately, there's no developers from our team tonight, but if you guys are interested into integrating our technology into your stack in your hacking purposes, I'm happy to connect you with our team. And also big thanks to Ocean people and the Nature 2.0 people for putting this together. I think it's very it's very great that we're all together tonight with the idea of hacking onto something, actually doing something right after a conference like Revision Summit. It's great to listen to people talking, but it's great also if we can start doing stuff. So thank you guys for being here tonight. Very happy to be here. All right, so IoT devices are, you'll probably notice this is a generic presentation that comes from DEF CON, so no offense. IoT devices are data oracles for the future autonomous M2M economy, all right? The problem that we have with this is how do we make sure that the data that actually come from at the sensor level is trustworthy, and how can we leverage this data? So the way we see things at Weeve is that we break down the value creation from data generating sources that are IoT devices into 5 different steps. That process is harvesting, processing, transporting, attesting, and then trading. And essentially, the way it works and what we're building right now is the following technology stack. I think for this hacking session, the MQTTS that you see here, and hopefully the testimony will be made available to developers hacking on the session. And I'll explain right now why that could be of interest for what you guys want to do. So at the very basis, what we have is the ARM trust zone. The ARM trust zone is some sort of a generic chip that is widely available and that essentially enables you to develop and to build application and run programs into what we refer to as the trusted execution environment. In that trusted execution environment, we are running an operating system that's essentially isolating critical components of programs from the unsecure part. And what we do is that we create a cryptographic proof that can attest the authenticity of data at a software level that's happening on hardware. That's happening on the hardware itself, right? So many of you might find that a bit confusing, and it's true. It can be confusing because essentially we can prove the authenticity of the software information that the sensor is creating, but if the hardware itself is manipulated, in that case we cannot. But it's very important though that we have the proof of that data is trustworthy, right? Because otherwise you could have people simply manipulating, in the case of Nature 2.0, manipulating sensors that would be placed on, say, trees or so, right? You'd have someone that hack into the system and that say, okay, right, that forest is healthy, creating whatever metric you have for it, and what in fact it doesn't. So we can, at a software level, we can cryptographically prove it, and that's the purpose of the testimony that you can see here. Now, we also have what we refer to as MQTTS, which is a publish and subscribe communication protocol for IoT devices. The little S at the end was added because it's some sort of a wink to MQTT, which was the original IoT protocol, publish and subscribe communication protocol. And then we have the Fair Exchange and blockchain sort of acts or project or stuff that we're working on, although right now I would really like to empathize on MQTTS and testimony for Nature 2.0 projects. Yes. Yes. That's a diagram um, that I wish I could go into detail with. Essentially, we're going back to the trusted execution environment, and that trusted execution environment, as I mentioned, is sort of separating the normal OS from the secure OS. I mean, if some of you are like familiar with this type of chip, you already know this. But this is where we are leveraging essentially our testimony and MQTT protocol from. We can create a testimony core or a crypto API in a blockchain crypto API and like a wallet in a secure storage inside the chip that you have running for your edge devices. And that's very important if you're looking at, I don't know, managing commons that would be, as again, as mentioned, a resource like a forest or a river or anything like that, really. I have to, okay. Oh, yeah, sorry. Yeah, I think that slide can also be skipped. I mean, yeah, you can read through it, but it's like, yeah, something that efficient, that snarks, yeah. I mean, I'm happy to take on questions actually. Then there's the next slide is like our partners, which is something that is not particularly relevant to this event, and then our GitHub that you can still like you can always check out. But if you have questions regarding Weave, what it does and how it can help fit into this hacking session, then please reach out to me and yeah, that's it. Thank you. Dimi?
What are you guys are using an ARM chip, huh? ARM chip. Are you distributing them for your friends and family, or should we buy them somewhere, or how do we get access to that hardware? How do the developers in Nature 2.0 can play with Weave? Do you guys are gonna give away some chips?
So that's a question that I'll try to ask to the C-level people. I don't know. I know like some chips, yeah, a good portion of chips are actually by default enabled with ARM trust zone. So it's something that you definitely find in any type of phone, for instance. I don't know. I like that's something obviously if some people are interested in working on with us on that project, we can definitely provide the developers with the suitable chip, I guess. Yeah. Thanks for the question, Dimi. Oh yeah, there's one behind as well. There you go, sorry.
Question, do you employ actually in this cryptographic chips the same cryptographic method that you're using in the blockchain, or is it a different curve and different key lengths?
It's the same. I saw it on slides, by the way.
It's the same. Yes. Am I sure? So I no, but actually, it's great that you're asking those questions. Our CTO is a professor, doctor of cryptography at the University of Flensburg. So if you have any cryptographic related questions, he was here a bit earlier, but he only stayed for the pizza. Fortunately, he had like some serious stuff to do. He couldn't attend. But if you do want to go in depth into cryptographic questions, then please reach out to him. He'll be really happy to answer. There's 1 minute.
No, you still have because the Amsterdam people are still talking. Yeah?
The Amsterdam people, okay.
So can I ask a question?
Sure.
Okay. So how could you help the hackathon teams or the startups that come out of the hackathon?
Well, I mean, first, I'm very happy to participate in this hackathon. So I'm not a computer scientist myself, neither a software developer, but I can try to help you in many different ways if you need support in your team. And I think the way we can help most is if you're looking to have trusted oracles within the system or within the prototype or the MVP that you're looking at building. So for instance, if you're looking to deploy, I don't know, a set of sensors in any sort of commons, that could be a field, a forest, or anything, you need to have that cryptographical proof at the software level. And I think this is where we can help, and Weeve can help. That was a pun. Yeah. Yes, thank you. Thank you for the slow clap.
I saw Weave was not only working on the hardware level, but also on the incentive level, where there is like cryptographic primitives like graded TCRs, and then there was more recently was not the CCR, but the KPI one. Are these things? How do you feel that's the relationship between these incentive mechanisms and what you can do for Nature 2.0?
Actually, to be fully honest, I try to think of like crypto economics primitives being implemented in the Nature 2.0 track. I just I think that AI as a whole might have a greater role than blockchain right now in what we are looking at building, especially applied to the commons. So I think applying sort of inner incentives mechanisms for self-governed entities like AIs that would run on top of a forest, for instance, is an interesting concept. But it's kind of a curiosity for me on like how to work out the crypto economics primitives that lay down these sort of incentives for the AI itself, or even for like people contributing to the commons. If you understand my answer. Yeah, not really. What do you think, Dimi? I mean, like, you can. How do you think crypto economics primitives can actually help Nature 2.0? Yeah. How do they fit into what we are looking at building here? Or if anyone has an answer to that question, actually, I'd be happy to share the mic. Yeah.
I mean, there are a lot of ways to. Let's think about the form of a lottery. A lottery basically gives a lot of people the opportunity to get a big winning. So that's basically a big incentive for people to play in that lottery. That lottery doesn't have to give 100% of its winnings towards the winner. It can give 80%, you have 20% that can go to other resources. You can think about UBI, you can think about other types of allocations of funds. And that's now the very simplest form of game incentive, extracting rent from playful behavior of humans. There's other ways to do this. So maybe that's something. When I heard once in a talk that on the IoT, crypto IoT level, your toaster would pay off his gambling debts to the ice cream truck and what have you. So all these things are possible, actually.